All right, welcome back. We are Game 2014 in the fall 2020 semester at George Brown, Mobile Game Development 1, and it's week 10. Um, so we're talking about platforms and player movement a little bit more today. I'm also going to start introducing the AI stuff early. We have a lot of things to do with AI, and I don't want to wait to get going on this next week because it's going to eat up a big part of our time frame. So I'm going to just fix up player motion today and then start AI today to get you guys going. Okay. Just a reminder that this week you'll have Lab 7, which is due this Friday, and this is just following along. It's a follow-along lab like every other week. Assignment 2, Part 1 has been released and is due next week. And on top of that, what we're going to have is, just to be clear, we're going to have a test that's coming up on week 12. So 2 short weeks from now, it'll be a theory test just on the stuff we've talked about up until now. The theory, again, it'll be straightforward. It'll be open book. You'll have a chance to for 2 attempts, all that kind of stuff, and it'll add into your mark from a theory perspective. Again, this semester is all about foundational stuff. Next semester, you'll be doing something cool. All right. So that's what we're going to do, and we're going to be working on more with touch controls, adding enemies, and add simple AI sensing with line casting / ray casting. We'll talk about how to do that. Everyone does things slightly differently there. And in addition to that, what we're going to be doing is enemy motion. We'll talk about that. Patrol, more or less, is what we're going to be doing today. And then next week, we're going to add in enemy behavior. Okay, more than one enemy, perhaps, or other things. All right, let's get to it. So we have a GitHub project that I've asked everyone to download. It's this Game 2014 F2020 Lab 7 starter. It's up on GitHub under George Brown College. And you can continue from there. Okay. And so this is where we're at. And last week what we did, if you remember, is we had some clunky controls for control. And we had some weird stuff when it came to jumping, and I didn't like it, and we're going to fix all that today. So starting off, I've actually deployed this thing on a device. And on my Android, my little Android Samsung S7 phone that I have. And I found that maybe you guys found the same thing, I found that the control itself is too small. Okay, so I found that this was like way too small. Mine has been switching platforms to Android for 6:30 already. I don't know what that means. Sorry, 15 things to do in the class each week. Okay, I'll read that stuff later. Yeah, I am. And so what I noticed is that this was a little bit too small, so I'm going to make it bigger. So I'm going to go to the fixed joystick, and we're going to move that up to 2 times as big. And same thing with this, 2 times as big. And I know because this guy is going to be centered around the camera that we created last week, we can actually move this thing so that it is more to the left, slightly to the left, and up a little bit, because it doesn't matter. He's not going to be here. The camera is going to follow him, and this thing is going to be somewhere else. So I made it twice as big, or instead of 1.5, I went to 2 times, and I think this is pretty cool. Next, our jumping is something. So I'm going to save that. Our jumping is an issue, but before we go further, I want to start this with as a base project, right? Like we talked about. So let's put this the way it is, now that I've switched it and all that kind of stuff, up on GitHub. So to remind you guys how it's done, I'm going to file, save. I'm going to file, save project, and I'm going to close this down really quickly. So I'm going to bring up my command prompt. This is this, and I'm going to go to my files where I have my project, which is 7b, and I'm going to say git init, git add dot. We'll let that happen, and after that I'm going to clear the screen, git commit -m, and we'll say initial commit. This is the first commit that we're doing. Excellent. And then what we're going to do is I'm going to make a new repo up online where you guys can follow along if I'm a little faster than you. which is what we're going to do, right? So Game 2014 and the Fall 2020 semester, and it's Lab 7B. There we go. And what I want to do, come on, is grab the last 3 lines of code, go back to this, and right-click and enter, and then we're good to go. I will give bonus marks for anything extra you add in. Make sure you talk about it in your video, please. Okay. Remember that I will always try and honor the agreements we all make, which is you guys do extra, I give you extra. Okay, so let's get back to this and refresh this, and we'll start back with Unity. Again, I just wanted to make sure that I had everything running, and then you guys can follow along. Okay, so cool. We got this little thing here, but we want to fix the way that this works, because we talked about it last week. It was pretty clunky, right? And it's pretty clunky because of the way it jumps. The way it jumps is wrong. So a couple fixes. Let's talk about some fixes. One is I want to go to the player behavior. I'm just going to minify this stuff here. So this is the first thing we're going to change. I'm going to go to my, let's move this box collider up. And I care about player behavior. I'm going to double click on player behavior. Oh, one thing also is my vertical sensitivity, I'm going to move that up to like 0.5. I think it's probably better. Vertical force, we're going to switch back down to something smaller than this. And in a second, we'll see how that's done. So, like so. Here we go. And what we had before was we added all this stuff. All this stuff was inside of an update. And I think that fixed update would be best for us, because fixed update is better for physics. It gives us a better, less spamming, and all that kind of stuff. It hits update less times, which means chances are, from a delta time perspective, which is kind of what Michael talked about last week, we don't need delta time in our vertical force, which means we can use less vertical force, right? So we'll do that first. We'll fix this part. Okay, so I want to fix this part up first and then see how much vertical force makes sense. It's definitely not what we have right now. Okay, so let's try this out and see if this works. So go back. And I'm going to suggest 500 as a starting value. I think that's too much. It's probably going to be like a lot less. So let's see how this looks now. So if I'm playing and if I push up, that's not so bad, right? So, and if I push even up more, it doesn't matter, because, you know, it's kind of okay, right? Now he's pretty big. You know, he can jump a lot, but, you know, it's playable now, I think, when I move those two things around. So you can see that that's pretty cool. He can fall nicely. He can jump nicely. And I'm not killing myself trying to make him jump up and down. If he falls, and all this kind of stuff, because that's kind of one. Next, let's save that. And let's deploy this to LD player to make sure it works. I've already deployed 7A. I just want to make sure that we can deploy nicely with 7B. So build settings, build and run. I'm going to make a new folder called builds. I'm going to go into the builds folder and make lab 7B and press enter, let it deploy. Okay, so these are the things we want to try and do. Russell, could you go over what you just changed? My project was still opening. Sure, I can do that. I'm just waiting for this to deploy, and then we'll try it out. I want to just try this because I want to make it playable. And sure, we could add another button and all that kind of stuff, but I find that adding another button makes it so it's very difficult to play and demonstrate at the same time. I was working on a way of showing my Samsung Galaxy S7. It didn't work great, to be honest with you, so I'm I wasn't happy with the streaming to my computer from my phone thing. It didn't work great, so I decided not to go that way. There's no requirement to use the on-screen joystick in assignment 2. I'm doing something different for movement. Yeah, you can use the accelerometer if you want. It's up to you, right? I mean, you can do, as long as you use touch, that's fine, because it's got to work on a mobile device. But something to do with mobile input, I'm fine with that. All right, so this is going to work in a second, and let's see how it works on LD Player. Again, we want to check it at least one time to make sure that it's good, and then I'll go back and go over the stuff I changed. Alex. And one day when this feels like doing what it's supposed to do, it's going to copy things over, and it actually deployed to my phone, not to my, not to this thing. Well, that's okay. I meant to go here. Notice my phone is connected, so if you could see my phone, it looks great, but that's not what I want. I want it to go to here. Let's try this again. Oh, wow. That was bizarre. Well, let's see how, for people who are watching, I can actually do the thing on my phone, and it says allow access. Sure, allow access. So you can see that this is the phone thing working for people who can watch this thing, and it's okay. It's not a bad way of doing stuff, but you know, even from the side, it's playable now, at least from what it was before. So that's pretty cool. Yeah, so I was trying to deploy the phone. You guys can't see that here, but I'm actually showing that on the video. But obviously I have to make it work on LD Player, not on my phone. And let's try that again. There we go. Okay, cool. So there's the thing now. You can see that this all works. And I can move back, I can go forward, and boop, it's going to work great, and it's good enough for us. Okay, that's what I was going to show you. Fantastic. So this all works. Okay, so Alexandra's question, which I want to make sure that we know about. Well, in my scripts under player behavior, I changed my update to fixed update. That's the first thing I changed. Fixed update works great because it does less updates than the regular update does. The regular update works much faster. Fixed update works great for physics, and when we use physics simulations, then fixed update is just a better choice in general. It's more deterministic than the regular update does. So that's the first thing I changed. Second thing I changed was I took away the delta time from the up force because we're not spamming as much anymore, just like Michael said. And so we can take away delta time, which gives us the ability for us to push up, and it works. That's nice. The other thing that we're going to change, we changed on the project, is we made our control in our canvas, our fixed joystick, we made this twice as big. Or sorry, we went to a 2x scale for everything instead of a 1.5 scale, and I pulled it to the side here a little bit. Those are the things I changed. So hopefully that'll give you everything that you need to know. Okay, so again, you can pull down the project from online if you're running behind at any point in time. And I'll stop my phone from running this thing. Okay, so cool. So this is what's happening here, and I want to do a couple things. Russ actually mentioned something that's interesting, and he didn't like the fact that I wasn't using an enum. I'm going to use an enum, but maybe not the way he wants. Sorry, Russ. But I'm going to create a new C# script here, and I'm going to call this the player movement type or player animation type. We'll call this player animation type this time around, just to make it different than the other group. My player animation type is going to be system serializable. So let's do that. So system.serializable. So we can share it. We're going to make it so that it's not mono behavior, and doesn't need these, but it's rather an enum. So we can change this to an enum. And we can set the enum type. So idle will be the first state. Second state is going to be run. There's going to be a jump state, as well as we'll add crouch to today. So we'll add crouch. So 0, 1, 2, 3, right, for those kind of things. And what we can do is we can replace what we have instead of numbers in our code, because we're going to forget one day. In here, we can replace these numbers with our enum type. So we can say something like int, and this is not what Russ would recommend, but it's okay. So we're going to say player animation type dot, and then it's going to be run, right? So when we look back at our code, we're like, okay, I know what's happening here, kind of thing, right? I know what I wanted, right? And because otherwise, one day we're going to go back here and say, what does this mean again? What does that one mean? What the 0 means? It doesn't make any sense. But this is more descriptive. At least it's kind of a middle ground between probably what Russ wants and what we're doing. And I'm just trying to make sure that we're all happy. Oh, that actually is how you use your emotes? Oh, okay, I didn't realize that. Yay! I didn't mean that. I meant it in like, I thought you meant it in a different way. This is how I kind of do it when I use enums. I didn't do it last time because, I wanted to get going. But yeah, I could use a string, but my only thing with a string is, Shimron, that I don't like the finger typing error. Even this anim state thing, I'm not happy with that. I think it's bad. Because if I do a finger typing error here, this is going to end up being a bad thing. Yeah, oh yeah, I'm only using one parameter. That's right. And you can use many parameters here to make it more, to transition this nicely. Okay, so I want to add a crouch state to my little player. A crouch state. All I've done is I've added player anim type run, idle, and so on. I'm going to add a crouch state now. So let's do that. So just like before, I'm going to go into my external resources. Under Sunnyland, there is artwork for the sprites. There is the player sprite. There is a crouch. It's also climb. Crouch, I'm going to make sure before I go there, I'm going to change the player pixels per unit to 16 and apply so we have the right level. Take the crouch animation, pull it into the scene, and rename this thing to player crouch clip. So again, it's going to go into the right spot too. So assets, animations, platformer, player, and then it's going to be player crouch clip. Player dash crouch dash clip, and that's going to add in that animation. We can actually now delete this one because we just use this as a vehicle for us creating the animation. Going back to the animations inside of our platformer player, we can get rid of the player crouch 1, which is our extra controller that was created, delete. And we can use our animator controller here. I'm going to just change layouts so we can see it bigger. I'm going to go to a tall layout for a second. And let's go back into that player animation. And just pull this in a little bit. Right, so we have jump, run, and we want to add idle. So I'm going to do that. I'm going to pull in the crouch clip. So pull that in here and pull exit away. And we'll rename this to crouch. So we can't really jump and crouch at the same time or go from jump to crouch. We can jump, land, and then crouch. So it's going to go through idle to get to crouch. At least that's how I see it. You guys can see it differently. But I want to make a transition from run to crouching. So I want to do that. From crouching to running. From idle to crouching. And from crouching to idle. We want those things. And just like before, we want to take away exit time from all those things. So no more exit time. And just like before, I'm going to take away some of the blending rates between these two states. So from idle to crouching, I have idle. I'm going to pull this part to the end to 100%. And I'm going to reduce this to 90. So go all the way to 95, let's say. And pull the crouch over. Because I don't want to blend. Yeah, I think it's true. I'm not sure if I'd want to do that, Patrick. So that's why I'm saying it's just going to be like so for me. But again, you can change yours if yours works well. Go ahead. Again, I'm going to do the same thing here. So I'm going to bring this part. Now this is the from crouching to idle. So again, I'm going to go to right there. Oops. Yeah, that's it. And this should be at 95%. This is my standard. Everyone does things slightly differently here, so but I like to go 95%. So then I've got these two transitions done. Let's do these last two transitions. Again, so from crouching to run, that means crouch is on the top. That means I'm going to take this down to 95%, which is in there. And then pull the running there into the 0 mark. Good. And the same thing goes on the way back from running to crouching. So again, we'll move this into the 95% mark. Right? And this is going to come in just a touch, just to get rid of that extra run animation. And like so. So that's running to crouching. All right, so that's the animation done. I've got it marked. This is going to be crouching. We need to make the variables work. So from here to there, I'm going to make a transition. That means the anim state is going to be equal to 3, right? And from crouching back to idle, the anim state is going to be equal to 0, okay? From crouching to run, the anim state is going to be equal to 1. And from running to crouching, the anim state is going to be equal to 3. These are all the same kind of things. So we're saying 3 is crouching at this point, right? I would have liked, Russell, just going back to what we said, if this actually showed us the a pull down, and if there was an option for an enum here instead of an integer, but we're asking for too much. And they use this differently anyway nowadays. This is the old school way of doing it. Okay, so it looks like our transitions are good. So equals to 3, this equals to 1, this equals to 3 on the way back, this equals to 0. Okay, so these are all good. Cool, save. Let's exit this one and go back to the game. Are you with me? Check mark if you're with me. You've done the animator controller changes. Some people may not have, but this is good practice. You guys should be well on your way to understanding how this works now, because since you've been with Joss has gone through this with you. Okay, I'm going to clear this up. Thank you for the feedback. Let's move into it. All right, so back to the code. So I'm going to go back to scripts and my player behavior script. Now I'm checking to see if I'm grounded. This is cool. And here I'm checking to see if it's jumping. I want to do a crouch, and it's going to be a copy of this kind of, but we're going to have some problems when I do this. So I'm going to put a copy of this. So I'm going to say if it's less than the negative joystick sensitivity, vertical, and I'm not jumping, right, then, because I can't jump and do this, then I want to say that crouching, I want to keep track of crouching now, not jumping. So I'm going to put another variable in play right now, temporarily. We might move this later on. We may not need it. Is crouching, right, just to kind of understand what's happening here. And I want to say that if I'm not is crouching, then just like we did before, is crouching is equal to true. Otherwise, is crouching is equal to false. But we're going to have a problem here. One thing is we don't need to add any force. We're not going to burrow into the ground. So we can get rid of this. This isn't going to be a jump. It's going to be a crouch, right, for this to happen here. But we're going to have a problem, right? Yeah, I agree, Russ. We're going to have a problem with this because of the way we're doing it right now. We're saying, okay, if this is true, then it's crouching, but then we have a problem. What if I'm crouching? Can I run? Really? Not really. So I'm going to say, yes, I need to be grounded, true, but I also need to be not jumping and not crouching, all right, for us to do this part. So I'm going to make another condition. I'm going to say that if not is jumping and not is crouching, that's the only time you can run, because you can't run and crouch at the same time. So I'm just going to grab all this and we're going to put it inside there. And now we don't need to do this little thing in here anymore, right? because the only time that you can move is if you're not crouching or jumping. All right, that's what this does. So yeah, that's pretty cool, right? Let's see if that even works or if that is a mess up. Okay, so crouching, cool, la la, and we just want to keep track of crouching because we want to be able to track state. Again, we could use a state machine here instead of conditional statements like this. It's totally up to us. Let's run this thing and see how this works now. Can I even crouch? And the idea here is that you should be able to run. Ooh. Why? I love when this happens. Is this what you're talking about, guys? When our build settings are back to something else? That's bizarre. Oh, it's probably because I didn't go into portrait, landscape. All right, and let's run it again and see what happens. So run. So again, if I crouch, that's pretty good. I can jump from crouching only if I get up. And if I run and like for a bit of time and then crouch, right? I should be able to run and crouch. So run, oop. And I should be able to crouch so I can, so if I build up enough momentum, I can crouch and then go maybe underneath something. All right? Or crouch to avoid disaster. So this is pretty cool. The jumping is okay. Maybe the jumping is a little bit high. I'm not sure. But this is pretty cool. Crouch. Again, I'm just testing stuff out. Now, one thing I don't like is this, that you can jump off the wall. I'm not a wall jumping kind of dude. I don't want this to happen. I only want you to be able to jump because the way we've done this, our mechanism, we only want to jump off of platforms and maybe off the corner of this top one. That's the only time. But the wall, I'm going to say no. This is my design choice. You might say, well, wait, I like wall jumping. True. But I want to talk about, I'm using this as a vehicle to talk about something else. I'm just going to go back to save. So I've got crouching in play. I'm going to go back to my layout, which is going to be the tall layout. I'll go with Tom's layout. There we go. And we'll just make it so that it is going to be this way. Good, so I can switch back and forth. Yeah. And I'm going to go back to the grid. So I want to talk about the grid for a second. The tile map itself, right now there's two layers, the tile map and the depth plane. Remember the depth plane, what we did before was we turned off the tile map renderer for the depth plane. So it actually exists down here. But what we've done is we've turned it off because we don't need to see the depth plane. That's kind of what we did. All right. And in the simulator, we're good. The scene is good. All this is good. Let's turn on the gizmos again. Just want to see the scene. So this is what the scene actually looks like. So what I want to do is I want to separate the walls from the platform. And a good way to do that is to get rid of, or to copy the tile map the way we have it and make another one. So I'm going to take the tile map. I'm going to press Control D, which is going to make a second tile map with the same name. I'm going to call this walls. And I'm going to make this one, this tile map, platforms. So walls and platforms. Okay. And I'm going to move walls up a little bit. So platforms and walls. I'm going to hide platforms right now. And I'm going to hide the depth plane. And I'm going to bring back my palette for a second. So I'm going to go Window. I'm going to go to 2D, Tile Palette, which is going to bring up my palette. I just want the eraser because this is just the walls, right? I've got only walls turned on right now. So I want to get rid of the tops. So the tops are going to be gone. So there's not going to be any of this. The platforms are not going to be included in the walls. Just this part. Now again, you can include or disclude. You have many layers here if you want. You can have as many layers in your tile map as you like. This is just my way of doing it. All right, cool. So this is this part. And what I want to do now is I want to turn off the walls and turn on the platforms and erase the other stuff. So let's just do the same thing. I'm targeting platforms up here and I'm just going to erase everything but the top platform. And my strategy here is that we can only collide with one thing in order for us to move, or to detect ground, if you will. And we're going to do that for the enemy too. All right, so then we can turn back everything. We can turn back everything back on, and everything looks good, right? Everything looks like it did before. All I've done is split the layers. So platform and walls are on different layers, and this is just a strategy. Okay, also one thing to note is my player right now, when it comes to the sprite renderer, he is at, or she, we don't know, it's, we don't know, he or she, they are at order and layer of 0. We want at least something bigger than 1, so let's make it 2 for now. So that way it's on top of everything, otherwise we'll be lost. I also want the box collider that I'm using for a trigger from last week. I want that to be a little bit smaller, so I'm going to just make it slimmer. So that way, if I collide with anything else, then and I'm going to use this box collider as a means of colliding with checkpoints and that kind of stuff as I draw my map. Okay. So cool. I've made my little guy made my little character, I should say. And now when I run it, we're pretty good. We can jump, still pretty high, crouch, right? No problem. And you can jump and then land and crouch, right? Which is what we want. And we can change directions pretty easy, all right? Cool. And you can notice how on the right here, it's going to show crouching when we're crouching, jumping when. Now this is something that's interesting. Jumping didn't fly actually. Take a look at that. So jumping didn't actually turn on. Let's see why that didn't happen. We should be able to detect when everything is happening. So let's go back in to see if that even is needed anymore. So if I go back into player behavior, let's see when is jumping is happening. So is jumping is true, right? And this only happens once, is jumping, right? And then is jumping is false, right? Because it happens all the time. Because guess why? Because the problem with this is that it only occurs for a very brief moment because we're not grounded. And if we're not grounded, this is the guard, then we can't jump. We can't jump, which means even if I press up the joystick anymore, the jumping is going to be so temporary that it's going to stop us. For again, we're going to keep this in, but probably in a future iteration when we refactor, we're probably going to take this away, and we don't need it. Okay. So that's kind of something that we're going to see. Okay. I'm just going to close my door, guys. I'll be right back. Oh. Okay, there we go, that's better. All right, so this is pretty cool, right? We've got some motion, we've got everything, but we want to add some additional challenge. So what I want to do now is I want to draw on the platforms level. On the platforms level, I'm going to bring up my palette again. So we're going to go to 2D tile palette. Here's my tile palette again. And I'm looking at the platforms only, so only platforms. So you can choose which one you want, wall or platforms. By the way, let's not forget the death plane. Let's turn that on. That would be very bad. And what I want is on the platforms, I want to draw my new platform. So again, I'm going to go here, and we're going to make it 2 apart. That looks about right. But instead of making it 3 up, we're going to make it only 2 up. So it's going to be 1, 2. So kind of over here like this time around. Right? And I'm going to draw just a couple of shapes, right? Just to make the platform a little longer, right? And we're just going to make it like this. I guess that's going to our first part of our platform. Now, here's the challenge. I want to use this part. And we're going to make it so that you can climb up. Maybe another one. And then I want to go across again. So across for a couple steps, right? Maybe add that in there to make it variation. And then I want to go up 1 to this, maybe like this. So it's enough to block. I have to jump, right? and add some more platforms stuff, right? Maybe make it one more, a little bit bigger, and then on the way down again. So this is where our enemy is going to live on the other side of this platform. So here, and we're going to get down here, and the enemy is going to be somewhere over here. Okay. Way over here. All right, so that's going to be our platform, right? It's a bit of a longer one. What I want is I want to spawn the enemy here. He's going to walk across here, stop here, and come back. That's what he's going to do. He's going to keep going there and back over and over again. That's the plan. All right, let's target now my walls and go back and put the walls back in. So put the wall in all the way down here. Again, separation, right? And put the wall at the bottom, draw it in, and the side. We don't really we need to fill in the middle, but whatever. And now it's this part here, which we want to fill in. Let's see if I can. Can I do that? Active selection. Or can I do, sorry, paint a filled box with active brush. That's what I want. Yeah, let's go on there. It's much better. And there we go. All right, so yeah. All right, so that is this. I've got my little plane, and awesome. I can turn this off now, and we've got our thing that's off screen, that's over here somewhere. Well, we see it just at the corner of our level, right? Cool. Save file, save project, and I want to add in my enemy now. All right, so I want to add my enemy in this part of my code, or my area. So again, going back into my Sunnyland, I'm going to go into artwork, into sprites, and into enemies. I want to pick the opossum. Why not? And in the opossum, kind of looks more dog-like. I'm going to put, he's going to be at 16 pixels per unit. I'm going to grab all these frames and drag it in to create the opossum. And I'm going to call this opossum dash run dash clip. And it's going to be in the same spot. So it's going to be in assets, animations, platformer. Instead of player, it's going to be an opossum, right? I want to put them in there. And save. Let's just fix that up. So I'm going to go into animations, platform, opossum. You see that I have a opossum run clip and an opossum animation controller. Let's rename this thing so it is what it is. Opossum animation or animator controller. Just so we know what it is. I'm not going to add more animations to this guy anyway. I'm just doing this for completeness. Cool. So I've got my little opossum dude, or doesn't have to be a dude. It's an opossum. All right, and here there he is. There they are, right? And we're going to bring this up and across until we get to this point. And this is where I want them to be, over here on the corner. They're going to start going in this direction, and then they're going to turn back. All right, so I need a couple things for them. One of them is I'm going to add in a rigid body 2D, right? Because it's going to move. The opossum is going to move just like the player moves, right? In many ways. The constraints are going to be on rotation. We're going to freeze rotation so that they don't turn over when they move, right? I'm also going to add in a collider. So it's going to be a capsule collider 2D. And my capsule collider 2D, instead of it running horizontally or vertically, is going to run horizontally this way. right? Because it's shaped the way that this thing is shaped. And I'm just going to tighten it up. So we're going to bring this down a little bit and to the back. And it may look like this thing is off, but actually if you see the animation, this is about right on the bottom. Okay, on the front, we got to be, I want to bring it in even more, because the more curved it's going to be, the better. If it's squarish, that would be bad, right? And again, we may want to rethink this, but this is probably a good shape for this thing. All right, maybe even bring in that the top even more, because it's not like, sorry, I'm limiting myself to this thing because there's only so much the top can be brought down. But something like this is good. Okay, tight little collider. All right, cool. So when we play right now, let's take a look and see what it looks like. If I go back to the scene, you can see that the bottom of the feet is running perfectly. This is what the animation looks like with the wagging tail. Pretty cool. And if I was to lift this up, then it's going to fall back down, which is kind of what I'm looking for. Okay? Are you with me? So check mark if you're with me, X, you're way behind, or you're just watching. All right, so good. You guys are with me now. I got a little enemy happening right now, and then we'll put this up on GitHub in a sec. All right, cool. So thank you for that. What I want to do now is I want to make it so that this little guy has a behavior. Let's add that in. So I'm going to go to scripts. I'm going to add in the opossum behavior. And we're going to attach it to the opossum. There we go. Chasing that one. Here's the opossum. There's the opossum behavior. And inside the opossum behavior, I'm going to double click on this. And we want to talk about what what we need. We're going to use force, right? So we need some kind of run force. So I'm going to put that in as a public variable. Public, we'll call this float run force. We need that. We also need access to the rigid body. So I'm going to say public rigid body 2D, right, is rigid body 2D. Let's make sure that that is taken care of here and start, where rigid body 2D is equal to get component rigid body 2D. Right, so that takes care of that. So we got rigid body. Yes, we need to do this for forces, right? We also need some other things, but slowly we'll get there. So we want a move method. So for now, we want some kind of move method, and we also want to know if it's grounded, because we don't want it to move if it's not grounded, right? So let's put a move method in place first. So we'll say void or private void. Well, we don't have to, but I'm doing it this way anyway. And we'll say that the what we want to do is we want to add force. Add force. And what we're going to do with the force that we're going to add, because we're going to push it along, right, at a certain rate. So we're going to say that rigid body 2D dot add force, right, and the force we want to add is basically going to be a new vector, right? Okay, we're going to add a new vector based on the vector to left. So we're going to go to left first, right? Multiplied by the run force multiplied by time dot delta time. Got to add that in, otherwise it's going to be insane. Capture delta time. Time dot delta time. All right, so that's going to be the force. And we need to add some kind of run force at the beginning. Let's see how this works, just like this, and see what we get. And we have to obviously call the move inside the update. We want to use fixed update, just like we've done with our player, because it's going to be more deterministic. Okay, and let's see how this works. Right, so is it too much? Well, we're going to add a run force right now of 100, and let's see if this is good enough. So we'll run it, and does it even move? We don't know. Let's look at the scene and see what's going on. All right, so what's going on? Well, is 100 not enough? I mean, how about 200? How about 500? All right, that's pretty cool. 500 is enough to get me partly upway, but not really much farther, right? How about 600? How about 700? How about 1,000? Not enough, guy. Not enough. There's a block here. Why is that? Because of the way these things are shaped. We're going to fix this in a second. How about 2,000? Oh yeah, it's going to fly now, right? Let's try that again. So going back. Let's go back to the scene. Let's go back to this. Let's start at 700. And just like Kat said, let's see what happens with 700. It's going to just fly, fly, fly away. It just flew away, right? The block was basically this piece up here. And I brought this into play on purpose. I wanted to kind of show the challenges with a bit of this thing here that we got going on, right? We've got a platform that we created in the level, and we made this. Now take a look at these little slots here. It's kind of like by default, it's created these little divots. And these are physics shapes, right, in our platform. Okay, physics shapes. What we want to do is I want to go to the tile map, and I want to go to click on any of the tiles, right? And what I want to do is I want to double click. So up on the top here, right? What I want to do is I want to open the tile map, this thing here. I want to kind of open this up, and I want to edit the tile map itself, right? Because the palette is one thing, right? But this tile map, right? If I go to properties, right now, you can see that I've got a couple things here. This is the same properties that I find on the right. The collider type is a sprite or none. So the sprite itself has a collider. Let's go to sprite editor. And when I go to the sprite editor, this is the actual sprite sheet itself. And that means that the sprite is using kind of best fit. So this is sprite. And if I look at the physics shape, there's a couple things here, right? One of them is that the physics shape has automatically been determined when I created this thing, right? Or when we did. That's what's happened. And what I want to do is I want to make the physics shape a custom physics shape so we can make it trim down a little bit, right? So to help us, because that physics shape that we had previously was no good. All right. So again, you can see that if I said custom outline, that creates an outline for my sprite. That's one thing we can do. We can actually make the outline on our own, or we can make a custom physics shape. Custom physics shape basically says, okay, I want to add a point, and I want to draw my physics shape. So by default, here's my physics shape for the outline. So this is the collider, if you will, right? So I can maybe you got to be very careful, and you got to be kind of consistent where your collider is going to be. Do you want to be inside the shape like this or outside? I mean, to me, this is kind of like grass. So it's okay if the guy rides or the opossum or anybody rides inside the grass. I'm cool with that, right? Same thing with my other physics shape here. So I want to make my other physics shape. So I'm going to draw this part and make sure that it's the same. Make sure that it's in pretty much the same location as the other one. If you don't, then we're going to have a bit of a problem. So see how that works? So now the physics shape I've drawn is different than what we had before. Let's also do it on this side because we have it on both sides of the equation. Not just for them, but for us. We're going to have the same problem, right? We're going to have to jump up the hill instead of pushing ourselves up the hill in a sec. So again, I'm in the sprite editor and I'm choosing a custom physics shape. So I'm going to do the same thing. By default, I'm just going to put this at the bottom. move this all the way down. And so you can see now the tops of the grass are cut off. That's okay. And the same thing goes with this one. So I'm going to kind of do the custom physics shape all the way down and all the way to the top. And again, you should be able to do one of these, and between the two things, it should be okay. Custom physics shape. You can do it for the other ones as well. I want to click apply here. All right. By the way, you can also click generate, and it says generate new outline based on mesh detail values. So this is another option. I've just made it myself. Okay, there's nothing wrong with generating. Sometimes it's pretty good. And you can turn snapping on or off. Right now it's on snap points to nearest pixel. If you don't want to, you can make it so it doesn't do that. It's totally up to you. All right, so this is pretty cool. We've done this. Now let's see what difference this makes when it comes to going up this ramp, because this is a problem for our little guy, or opossum. And let's see if they're able to move. I've limited his movement still to 100 for now, just so I can track him. And let's go to something like 600 and see if that's enough. 600 seems to be good now, but they still fly. So that's not good. We want them to slow down, right, as they move. So let's do it again. So, but the hill is not a problem anymore. Let's go back to the opossum and change this to a lower value, like 500. And let's see if that's good enough. Almost. That's pretty good, right? So that's pretty good to kind of bounce over. But we want him to slow down a little bit. So when he's running, he's going to build up speed. We want him to slow down. So in code, so I'm going to go back to the model and go back to the opossum behavior. And in the opossum behavior, I'm going to say that, yeah, it's okay for them to move, no problem. But at the end, we're going to say that the rigid body 2D.velocity is times equal to 0.90f, really a slowdown. So it's going to slow down a lot more because we can't control his force like we can our player, right? Which means that, 500 won't be enough. All right, we'll have to put it up higher because it's going to slow down a lot. Again, there's other ways to do the same trick, adding more friction on the material for this for each individual thing here. But if I put 500 now, you're going to see that 500 is not nearly enough, right? 500 is not nearly enough. It won't go up the hill, no matter what happens, right? The other thing to do, let's try 1,000. So 1,000 might be better. Now it's just a value. Don't worry about the number. So again, if you see it now, you see that it's going to slowly make its way up the hill. And then as it goes, it's going to keep going and slow down enough where it's a reasonable pace, that it's going to continue to go until it pushes our player, which is weird. Look at that, because there's no, it doesn't matter. He'll keep running as long as, they can. It doesn't matter. It'll keep going forever. So we need somehow now to limit them, right? And we can use our trick, but the problem is that it's not going to work the same way. And here's where I'm going to go with this, right? So I'm going to go back to the opossum behavior. And in the opossum behavior, what I want to do is I'm only going to be able to move if they're grounded. So let's make an is grounded thing again. So public bool is grounded. We're going to change this later. And we're going to say that the only time they're grounded, we're going to do that little trick again. So we're going to say private void on collision enter 2D collision 2D other, right? And private void on collision exit 2D collision 2D other, right? Awesome. And we're going to say that, well, if they're colliding, if other.compareTag, other.gameObject.compareTag, I'm going to try this out, is platforms. By the way, we have to do this for the player too, to limit them so they don't double jump. Then only when they're on platforms, and then is grounded is equal to true. Otherwise, if we're off the platforms, then is grounded is equal to false. And I want to do this for the player too, so let's make sure that this is the same thing. So I'm going to grab this and go back to the player behavior and put that in here. So is grounded is true, and because basically it should be the same, right? For the player. Player shouldn't be able just to ground themselves on anything, right? It's going to be only on platforms, not on walls. All right, let's see how that works, and we're going to try this out. So let's try it. Back to the scene, back to our opossum. We can see that it's climbing the walls nicely, and oh man, he's still flowing. Even though there was no walls and we have control, he's got enough momentum to fly. Look at that. Like, his grounded is false, right? Well, we didn't limit him. Let's try this again. So now that we have the is grounded mechanism, what we want to do is we're going to say that the only way he can move or they can move is if they're grounded. So we're going to say if is grounded, then and only then. Well, yeah, I have to put all this in there for now. Let's see if this works for us. So So again, we'll go back. Oh, platforms is not defined. Look at that. So that's bad. Platforms, we have to make a tag for platforms. Let's do that. So add tag. We'll make a new tag for platforms. We forgot to do this. Platforms. And we have to make a new tag for walls, right? We got those three things. So platforms is actually tagged as platforms. Walls is actually tagged as walls. Wonderful. And now we should be okay, right? Cool. Let's take a look at the scene. Let's get to our opossum. Let's see what's happening with them. And oh, what? He kept going, or they kept going, and it's enough. There's enough momentum that oh wow, that kind of works how we want it, because you can see that the is grounded comes off, but the problem that is going to push the player off. But they're going to keep going, right? We don't want this to happen. What we want is not this. It kind of works how we wanted it to do, but we want to do the other way around. So opossum, it's not going to work. Sorry, this is no good, right? Instead, we'll choose is ground ahead. We're going to do a look ahead. So the only way we're going to move is if there's ground ahead. If not, something else is going to happen. So how do we do that? I'm going to just go to the opossum for a sec. And what I'm going to do with this thing is I'm going to put, first of all, let's put him on the ground as much as possible. And just to measure them a little bit. There we go. And what I want to do is I want to add a new empty game object. Here's my empty game object, 0, 0. I'm also going to add into my empty game object a dot. There we go. Again, you can tag them this way. And I'm going to move this thing so that it is underneath and just in front. I mean, literally just in front. Again, you can put it as low as you want, and we'll have to adjust the positioning in a bit. But this game object is going to be called the look ahead point. There's my look ahead point. Okay? So my opossum, my look ahead point, and we won't be able to flip them across the render axis anymore, because if we just did the flipping around the render axis, this point wouldn't move. Instead, we're going to have to change the local scale to -1, right? When it comes to, oops, undo. When the opossum, if I want to flip the opossum, I want to flip the render point to -1, And so this way, this little look ahead point, right, is also going to flip. Okay, that's the plan when it moves around. All right, so this is the look ahead point. It's looking just ahead of the opossum. And what I want to do is I want to draw a line. I want to do a ray cast, or a line cast in this case, from the opossum's center of mass to the look ahead point. Okay. Okay, so let's try that out. I'm not sure what you're talking about, Russ. It's all ruined. Class canceled. Okay, so let's go to the the opossum behavior. In the opossum behavior, we need to have access to the look ahead point. So we're going to say public transform look ahead point. Okay, there's my look ahead point. And what I want to say with this is, going back to this, let's make sure it's adjusted. Oh. Cancel culture. Okay, I want to drag and drop this to the look ahead point. So I'm just copying, I'm dragging it over to the look ahead point transform in here. Okay. And what I want to say is, sure, let's make a new function. We're going to call this look ahead. And we're going to do this before we move. So private void look ahead. And the look ahead point that we're going to do is we're going to say that, okay, well, our is ground ahead is equal to, what we want to do is if physics 2D dot, again, there's a ray cast. If we use a ray cast, we can use a lot of different things here. We have an origin and a direction, okay? And this is okay, but then we'd have to define the distance. And I don't really want to do that. It's easier for us to use a line cast. Our line cast has a start and end value. So start would be transform dot position, so the middle of the character, right? And then our end point would be our look ahead point dot position. Now we need a way of detecting the collision, and there's a couple ways to do that, but the easiest way is to create a layer mask, right? And so we want a layer mask in here, okay? That's what's going to give us our do I have a collision thing, all right? So what I want to do is create a layer mask object up here. So we're going to say public layer mask, and we're going to use the layer mask that we're going to call the collision layer. That's what we're going to call it. Collision layer. On our editor, it's going to look like this. Collision layer nothing. What I want is for the platform to have a collision layer called platforms, and the walls to have a collision layer called walls, and so on. So let's go into our platforms, and we're going to make a new layer. We're going to call this the platforms layer. We're tagging it and creating a thing. We'll also create a walls layer. And then we'll go back to the platforms and change the layer to platforms and the walls to walls. Okay. And once we've done that, and we've got the layer and the tag, we're using them from different reasons here. Then what we can do is, when we go to the opossum, they are only going to collide with platforms. So that's the collision layer that we care about. And just to move that up, I think that probably belongs a little bit higher up. So something like the look ahead point, the collision layer, and then is ground ahead. And I'm just going to make it so that's platforms. So platforms is what I want to collide with. So then, once I have the collision layer in place, in my is ground ahead code, I can say collision layer, right? So what this does is it says, hey, physics 2D, do a line cast from the middle of my object to the look ahead point, and then use the collision layer as a collision detection mechanism. Return true or false. True if I have a physics raycast hit. False if I don't. That's what this does. And then what I want to do is I want to do a debug.drawLine. And I'm going to draw a line from transform.position to my look ahead point .position with a color of green, just so we can see it. This is going to be in the editor only. Cool. So that is my look ahead. And my look ahead is going to check to see if there's ground ahead. If there's ground ahead, I'm going to be able to move. If there's no ground ahead, I'm not moving. Let's see how this works. Run it. And let's go back to the scene and see this guy moving. You see he's moving. And we can see that the look ahead point is good. And hey, look what happens there. They ran out of points, but he's not falling either, right? Look at that. You know, again, maybe not the best choice of collider, but you can see that they stopped right here. Why? There's no ground ahead. If I put the ground ahead on, right, then that's going to give me force to move forward. Okay? So that's exactly what I wanted. All right, so let's go over that again. So again, I had a layer mask. The layer mask basically specifies when I look at a raycast hit, which layer to consider. Otherwise, it's going to ignore what it's hitting. Okay. It's going to also, we're going to keep track of if there's ground ahead, and if there's ground ahead, only if there's a collision in front of us, then and only then are we going to be able to move. Otherwise, we're not. Okay. We're going to look ahead, and we're going to get a true or false based on the line cast we're going to use through our physics 2D. We're going to draw that line, and we're going to move there. So then that's what is ground ahead is true. But what if it's false? Well, then what I want to do instead is I want to switch directions. So I want to say that our rigid body, actually our transform dot local scale is equal to a new vector 3 object, which is a transform.localscale.x, transform.localscale.y, transform.localscale.z, and what we want is that the transform local scale .x is multiplied by -1. So whatever it is, whatever it was, it's going to be the opposite. So if it's 1, it's going to be -1. If it's -1, it's going to be back to 1. Now, this is just going to change our scale. It's not going to change our force. So we need to do that next. And what we need to do is we're going to use our local scale to do that. So we're going to say vector left, run force, timed at delta time, times the local scale, times transform dot local scale dot x, whatever that happens to be. Okay, so that's going to basically, when we switch scale, it's also going to change our direction. All right, let's see how this works and if it works at all. I like that. I like that. That's a pretty good idea, Kat. All right, so let's see how this works. So we're going to go here. We're going to see our little opossum. He's trying to get up the hill. He gets up the hill. He goes this way and then flips. He goes the other way. And now he stops right there. Why? Ground ahead. Right? Look at that. So the ground ahead is too high up for the ramp to go down the ramp. They can go up the ramp, but going down the ramp is a problem. Right? So what we want to do is want to capture them. As they go right here. So see where that is? That line that's being drawn. So the look ahead point, they're swapping look ahead points now for a second. There it is. And what we want is for it to go lower, like down in here, right, from before. So now you can see that we've moved our y value to negative 1.684. Let's try that. So negative 1.684 is where the y value is going to be of the look-ahead point. And let's try that now, because I want to make sure that they can go back and forth, you know, without going too low. And it's not quite what we want, right? It's not quite there. So it needs to be, you know, again, there's going to be come a point in time where they're going to flip over, and it's just because they lose their connection. So it needs to be just a little bit lower. So again, we don't want to go too low, because if it's too low, it's going to go into the other block, and then they'll be able to do it. So we want to go just a little bit lower. Again, this is the point right here. And I'm using a big kind of point, but really the point is right here at the edge. This is where the vertex is. So you can actually afford to go even lower, like right there. Okay? And that is 1.827, negative. Negative 1.827. Again, just adjustments for our going down the ramp thing. And I want to make it so that way when we do it, right, then we can look at the scene and they'll be able to go up and down the ramp, no problem, but not leave the ramp. That's pretty good, right? Look at that. Flips around, goes back this way, and we've got a patrolling enemy. Make sense? And it's going to keep going back up and down the ramp. It can navigate up and down the ramp a bunch of ways, back and forth. And it's going to keep doing that forever and ever until we kill it somehow. It's not perfect, and there's some other issues. Visually, it does not do the job. Okay? For example, what we should do visually, and we won't do it today, we just want to make our enemy move and detect, right? Is think about what the enemy is doing here, right? The enemy is going up a hill, and so what we want to do is detect the ramp first. If the ramp, and what happens if by the by, right, I have a block here? What's going to happen then? That's an issue. Right now, our design is okay for this, but what happens if I put a block? Is it going to stop? Is it going to be? It's going to choke. That's a problem too. It's got to also look ahead in front of it. Not just this, but also in front. Look in front. So look ahead down, look down and ahead, and look in front and ahead. And if in front it becomes up to a wall, it should, you know, turn around too, right? Let's change our you know, platform a little bit just to make it so that exactly is what we're talking about. And then we'll take a break. So yeah, so we have our platforms, but we want to make it so that at the edge over here, we know that it's going to stop, but at the edge over here, we want it to bounce back from a wall too. All right, so let's go and draw it. So we're going to go into our 2D tile palette, and we're going to go back into, we're going to make sure we draw on the platforms, not on the walls, right? And we're going to get this and we'll erase it, okay? We're going to put a platform up here, right? And we're going to make this a wall, okay? Because that's how it should be. So, at least by what my estimation is. So here's where we have a platform up here, right? And now, well, actually we can undo that change. Let's make the platform here, okay? And here we want to put a wall, okay? Not a platform. So we're going to go to walls, and we're going to put a wall that's right here. Okay, something that looks like this. It's a funny thing, but it's for testing. That's why we're doing this whole thing, right? Cool, cool, cool. I like it. So again, if I look at platforms, it looks like this. If I look at you know, walls, I look like this, right? And what's going to happen? How can my little enemy, my little opossum, what are they going to do, right? When it comes to hitting this wall, this part right here. Well, let's try it out. And they're going to just get stuck here, right? So let's see what happens to them, right? So they're going to come up, and then they're just going to they're going to stay there forever. They're never going to turn around. Why? Because this only cares about if there's ground ahead. There is ground ahead. We just said there was, right? Well, this is a wall, so typically, you know, we would like it if this would turn us around. But what if there's like a big block in front of us? That would be a problem. So we want to have a look ahead point, but our look ahead point is looking down. We want to look in front as well. So we're going to copy this point, Control D, and this will be, you know, look in front, right? Look in front point. And you could call this look below, whatever you want to call it. But I'm just going to take this point, this look in front point, and move it up. And it's going to look in front, like directly in front of this little thing. Okay? So if this collides, if this line that's here, if this is colliding with something other than the player, right? Then we know that we have to turn around. Okay? Now we don't have to put it that far out. We can put it a lot closer. Something that looks like that. And all we care about is that this is colliding with something else. We don't care about what it is. Right now it could be a wall, and it could also be a the ground. It doesn't matter what it collides with. Okay? So we still need to use a layer mask, but now we'll draw it differently. So now let's go back into code. So again, opossum behavior. Now we'll make this different color. So we'll say this is going to be the, I don't know, purple color, which is this one. So we can see that there's two different points here. Opossum behavior. Let's go back into that. So our opossum behavior is going to have a look in front point, public transform look in front point. Okay, because that's what it is. Look in front, look ahead, and the other thing we want to do is, okay, it doesn't matter if it's ground ahead. Our look ahead point looks down and determines if it's grounded. But if we are looking in front, right, again, it really depends on what we want to do here. We can say we can call this, we can do both and look ahead, all right? Although single responsibility principle tells us that we want to move it into its own little case, right? So we can say something like look in front, right? Because we can then separate it easily. Void look in front. So what we want is, if physics line cast, we're going to physics line cast, same thing. The collision layer that we're going to use is a different layer. So this is a collision layer, but this collision layer is a collision ground layer, right? And we can't use the same collision layer in front. We're going to use a different mask. So this is going to be like we're going to rename this. So we're going to refactor, rename. So this is going to be our collision layer, collision ground layer. All right, that's what that's going to be. And this will be a new layer we're going to make. So collision ground layer, we're going to make another public layer mask. We're going to say collision wall layer. So this will be the collision wall layer. Okay, collision wall layer, collision ground layer. All right, so this is going to return true if the collision wall layer is, instead of look ahead point, it's look in front point. Very similar, look in front point. We're also going to, might as well draw it. We'll use a different color. So we'll say instead of color green, we'll use color purple? Red. We'll use color red. So color red, color green, and this is going to return true if there's a wall ahead. If there's a wall ahead, then what we want to do is we want to flip our local scale. So because we're doing this whole thing, and we're doing it twice, we're going to say flip local scale is another function we're going to use. Just so that way we can use the same thing. Because maybe we want to use that in some other way. So private void, we'll call it flip. Or flip across the x. And flip x will be this. And we'll do flip x here. Reuse. Right? And flip x up here. So if this is true, we just can say something like if this is true, then flip x. Okay. If we hit something, then flip. Otherwise, don't. That's what's going to happen. Okay. Makes sense? Look in front. This has got to be look in front. Thank you, Michael. It's going to draw in the wrong place, right? Collision wall layer, collision ground layer. And let's go back to this. So now we have 2 points. And let's change these points. This point here, let's make it so that it is red. And let's choose this point here, look ahead point, make sure that is green. So that we're using the same colors for this. We also have to make sure that the opossum knows about these things. So collision ground layer is going to be the platforms. Collision wall layer, well, that's going to be I'm going to make it both the platforms and the walls. Can we do both mixed? Yeah, we can do both like this, platform and walls. And you can add other ones, whatever else you want to collide with. So is ground ahead? Is this wall ahead? I can kind of track if there's a wall ahead, but we don't need to do that because it's only going to be momentary. It's going to see it and then it's going to turn the other way. Right? That's what the idea here is. We also need to pull in the look in front point. So look in front point's got to be in there. Again, this is something we may want to do differently later. All right, and let's see how that works. So does it work? So our little opossum goes forward and and then turns. That's kind of weird. That's very close. Okay. So you should have similar behavior. So it's going to try crawl up, and then, like I said, we can think about this another day. But that should work okay now. Take a look at that. And let's change our player. So let's see if our player can actually meet the opossum. So our player is right here, and hey, let's go over there, and we're going to go to there. And can we even go up the hill? Oh, not really, because that hill has got a problem. And right, look at that. That's a problem for us too. We can go down. That's pretty cool. But we have to build up to that. Ooh. And that's a problem with movement in general. And what happens if we get crushed? Like, that's a problem too. Look, they're never going to flip. I wanted to show you this because that can happen, right? So this is okay, but we can get that happening because we're on the corner. And so we come to the point where you know, there's some things that we can do here that are very similar to our enemy. Right now, the way we're jumping and grounding is we're jumping and grounding with colliders. And it might be best if we jump and ground through the same system that we've been using with our enemy. We've defined a problem with our enemy. We figured it out. They can move up the way they do. We need to do the same thing, right? But there's a couple things we should consider, and we'll talk about these things now. One, should we not change an angle when we hit our platform, our angled platform? Should we not, yeah, I'll show you that in a sec, Mike. Should we not also do the same thing by actually changing our angle so it looks like we're walking up? So when we hit the platform, we walk up. Isn't that something that we want to do? We're going to do that. We're going to address that here today. Let's go back to this. There we go. I'm thinking you've got enough there. So this is flip X. I just moved the flip, this part down to flip X. And I have my look in front, look ahead. That should be pretty much what we're looking at here. So that's a problem. And the other thing that I also want to consider is this. Right now, there is no value. The enemy is not really doing anything to the player. Maybe we want, when the enemy touches the player, that the player takes health damage. We need some kind of health system. These are all things that we're going to add in, right? Constantly flipping. Okay. Well, the only reason why they would be constantly flipping is if the position that you put in for your line, this thing, is low enough that it's colliding. Or if you're looking at the wrong, you put the wrong values in here. Be careful, because it could be that your look ahead, when you dragged and dropped your look ahead point and your look in front point too, make sure these are right, because whatever, it doesn't matter what it shows here, it matters what it does here, right? I did. So in the editor, what I did was in the editor, I have collision layers for the ground is platforms, and collision layer for the wall layer is platforms and walls. Okay. You could also just say everything, right? Anything that you collide with, even the player, you'll just move around, right? Oh, sorry. All right, so that's kind of our little thing. So that's what I want to do. I want to modify when we come back, we'll take a short break. When we come back, I want to modify the way the player moves, not just the way the enemy moves, so that the player also uses some kind of look-ahead mechanism, right? So I can't move unless I'm grounded by the look-ahead mechanism, not by a collider, because the collider has issues, like we just talked about, right? If I kind of hit the corner of a collider and I'm colliding twice, I get double the jump power. I don't want that to happen, right? So that's an issue. Let's do a couple things before we stop. I'm going to file, save project. I'm also going to push it across, so build and run. Let's build and run it across to our device to make sure that it's working okay on this, right? Because I want to test it. We can't see the enemy until we go find the enemy, but at least this way we can go across and see what it looks like. Hopefully it's not going to build on my phone this time again. Okay. So we're getting closer. Again, I know we're going really micro slow, and some of you may have already been trying a bunch of new things. But again, remember what we're trying to do. We're trying to build capability. This is foundational stuff. We're working on trying to get everything going so that way next semester you've got everything you need for 3D platformer, for example, or some other kind of thing altogether, right? All right, so we can jump, yay, and we want to run and jump over here, and let's see if we can find our guy, right? Our little. Now this is a problem. We know this is an issue, so we want to kind of jump over here, and hey, there's our little enemy. And don't crush me. No, enemy, don't do it. Right, there we go. So that's a problem because our little guy collided, fell down, and notice that I'm having problems getting up just like I did before, right? Because of the way the physics is over here, where we're using the physics. We have to kind of get a running start and I can get crushed by the enemy. We're not really taking any damage, but you know, this is the problem. And notice how far that my player was able to jump. Not good, right? Especially when I come here. Here's the issue. This is on the emulator. If I'm here because I'm colliding with this and this, I'm still getting potentially a double jump happening, right? So be careful, because this could cause me to do one of these. See that? That's wrong. So I shouldn't be able to do that kind of thing. And again, this is a problem. This is a problem. So how do we address this problem when we come back? One, we want to angle our player. We want to change the angle of our player, at least from an animation perspective, to see that they're moving up the ramp. Okay, that's number one. And two, we want to increase our speed when we're going up ramps. When I go up a ramp, I want to give myself a little bit more of a boost, right? When I'm going down a ramp, I'm going to slow things down. Okay, so up and down ramps are different. And how can I do that? Ramps on different layers. Just like ladders would be on different layers. Just like a lot of other stuff. You can use as many tile layers as you want to accomplish the same thing. All right, so that's where we are right now. Let's take a short break. I'm just going to stop this. And let's minimize this. And we'll take a short break. First, before we do that, I'm going to exit. And I'm going to put this up on GitHub, so if you're behind, you can catch up. So I'm going to say git add dot git commit -m. I'll say added opossum enemy git push origin main, and that should push everything up to GitHub. All right, let's stop recording. We're going to take right now we're sitting at 140. Let's take about 10 minutes, so about 150, and we'll come back. So I'm going to stop recording now.